So we're going over chapter 1, section 1, which is coordinate plane and distance formula. We're going to start with the coordinate plane. So the 2 points of intersection of the x-axis and the y-axis is the origin. The origin is always this point right here, so again where the x and the y meets. And the 2 axes divide the plane into 4 quadrants, labeled 1, 2, 3, 4 in the figure. The points on the coordinate axis are not assigned to any quadrant. So to elaborate on that, we have the different quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. They're all in Roman numerals. And the axes, just to reiterate it, don't belong to any quadrant because they all have a 0 at some point. Every quadrant has an x and a y coordinate, where we would have a xy coordinate in a positive manner. We have a negative x, positive y. We have a negative x, negative y. And here we have an x, comma, negative y for the different quadrants. The ones that are in the origin only have one of the 2 pairs, because the other one would be 0. In this case, in this side right here, we would have an x, comma 0. Here we would have a 0, comma y. Here we would have a negative x, comma 0. And here we would have a 0, comma negative y. That's why they're not part of the quadrants, because they don't really head into the quadrant. So now we have the distance formula. So from the figure 4, we see that the distance between point A and C on the horizontal line must be x2 minus x1, and the distance between B and C is the vertical, must be y2 minus y1. We only use the distance formula when it comes to stuff that are in a diagonal, that are not perfectly parallel to the axis. So what do I mean by that? We have the y-axis, this one's parallel to the y-axis. Here we have the x-axis, this is parallel to the x-axis. For those, you can just take the difference, as one of the other points is going to be 0. As well, for the vertical one, you just take the difference of the y's. And for the horizontal, just take the difference of the x. Now, if you were to use a distance formula to find those points, you would get it 2, as one of the terms would just cancel out. So the distance formula is, since the triangle ABC is a right triangle, the Pythagorean theorem gives us that distance of AB, so x minus 2 minus x2 minus x1 squared plus y2 minus y1 squared. Under the square root is going to be the distance. Now, in this first one, they have it with absolute values, and in the second, they have it with parentheses. The reason it doesn't matter in this case is because when you square anything, it'll become positive. So if you have a negative value inside of those parentheses, once you square it, a negative tends to be negative gives you a positive. That's why it doesn't matter if you put it in absolute values or in parentheses, because when you square it, the negative will disappear. And you guys can't have a negative distance. So the distance formula that we would be working with is this one. If I don't write it with D and then parentheses A comma B, I'll probably end up writing it like distance of AB. That is a notation I learned a while ago. That just tells me what distance from what 2 lines or what 2 points I am finding. You guys are welcome to write it however way you want, as long as you know where you are and you're able to mark your answer in a way that I can tell what the answer is for. So here we have applying the distance formula. Which of the points P or Q is closer to point A? So I'm going to write the distance formula, just so we have it. Is x2 minus x1 squared plus y2 minus y1 square, all of that under the square root. Now, I'm going to write here P, 1 comma negative 2, and A. Point A being 5 comma 3, and then we're going to do point Q, 8 comma 9, and A, 5 comma 3. Now, I am separating this because we're finding the distance from P to A and then from Q to A, as we got to figure out which one is further apart. Now, you've probably heard that x2 and y2 is always the second point. Yes, that is the case. Now, I don't mind which is x2 and which is x1, or which is y2 or which is y1. The key part is that you have to be consistent. I'll show you with both of these, if you flip them, what would happen. So for this one, I'm just going to mark them so we can follow along. This is going to be x2. This is going to be x1. This is going to be y2. This is going to be y1. So when I plug it in here, we're going to have 5 minus 1 squared plus 3 minus negative 2 squared. So I'm going to get 4 squared plus 5 squared. It's going to give me 16 plus 25, and that's going to simplify to 41. So the distance between P and A is root 41. Now, flipping the x and the y just to prove you guys that it's not going to matter. For the next one, this is going to be my x2, y2, x1, y1. When I do that, I'm going to get 8 minus 5 squared plus 9 minus 3 squared. So we're going to get 3 squared plus 6 squared. That's going to be 9 plus 36, which is root 45. Now, just so you guys see, if I flip them, it doesn't matter. I'm going to grab the Q and do it again, flipped, just so you guys see it. So if I do, you guys don't have to write it. 5 minus 8 squared plus 3 minus 9 squared. I'm going to get negative 3 squared plus negative 6 squared, which also gives me 9 plus 36, which at the end gives me root 45 again. The key part here is that you are consistent with your x's and your y's. So if you choose the q to be the 2's, stick with those being the 2's. If you choose the a to be the 2's, stick with them being the 2's. As long as you're consistent, you will get the same answer. Cannot stress that enough. When you start flipping the parentheses, is when the mistakes start to occur. Now, which one's closer? Point P is closer. This one is smaller, or yeah, it's less distance than root 45. So I'm just going to write down here. So P, so point 1 comma negative 2 is closer to A, so 5 comma 3. So to answer the question, P is the one that's closer. So they want us to find the distance between the following points. So we want to leave the answer in a radical form. So we have the distance for A and B. Again, the distance formula, I'm going to write it up here just so we have it. It's x2 minus x1 squared plus y2 minus y1 squared. All of that under the square root. So for A, I'll do it in red. I'm going to choose my A to be the 2's and my B's to be the 1's. So it's going to be negative 6 minus 1 squared plus 5 minus negative 1 squared. So this gives me negative 7 squared plus 6 squared, which then is 49 plus 36, which gives me 85. So my answer here is root 85. Root 85 I can't simplify, so that'll just be your answer. For 2, I'm going to choose D to be 2 and C to be 1. So when I do the square root, it would be 0 minus 10 squared plus 4 minus 3 squared. Again, as long as you're consistent, that's all that matters when it comes to these problems. So we get negative 10 squared plus 1 squared. That's going to give me 100 plus 1, which is 101. 101 is not simplifiable, so that would be my answer. Now for 3, I'm going to choose my F to be the 2 and my E to be the 1, just to be more consistent with what you've been taught in the past. It's going to be 5 minus negative 2 squared plus 7 minus negative 3 squared. That's going to give me 7 squared plus 10 squared, which is 49 plus 100. So my answer is root 149. Again, that is as simple as it can be. We can't do anything more than that. Now we're going to talk about the midpoint formula. The midpoint formula is, well, a formula to tell you the midpoint of a line segment from 2 points. So if we have point A and point B, we have x1 plus x2 over 2. That's going to give you the x of the midpoint, and y1 plus y2 over 2. It's going to give you the y point of the midpoint. Just so you guys are aware, or if you don't remember, I'll jog your memory real quick. I put them in different colors because these two are kind of separate formulas. They're the same thing, just different variables. Why are there different formulas? Because to find the x, you only use the x1. And to find the y, you only use the y1. I'm putting ym and xm as x midpoint and y midpoint. You're also maybe given the midpoint and you're missing one of the x's. You plug them in separate into the x with the x and the y with the y, and you're able to solve for the other variable. I want to reinforce this because when I taught geometry last year, this was a concept people had a hard time with, and you guys saw it at least 2 years ago, if I'm not mistaken. So it's probably something that you might need a little bit of reminding. So they want us to find the midpoints between the following points for 1 and 2, A, B, and then for C, D. I'll write the formula on the side right here. Again, I'm writing it in 2 colors, just so a reminder that they are 2 different formulas, or to find 2 different things within the same idea. Now, for 1, I'm going to choose A to be 2 and B to be 1. And then for the other one, I'll choose C to be 1 and D to be 2. It's not going to matter, again, as long as you're consistent. So here we're going to choose 17 plus 9 over 2. And then it's going to be comma, just for the other one, 4 plus 3 over 2. So that's going to give me 26 over 2, comma, 7 over 2. Now 26 over 2 becomes 13. And I'm just going to leave 7 over 2 the way it is because I don't want a decimal. I'll rather leave it as a fraction. And that would be your final answer. I'm going to choose C to be 1 and the D to be 2. Again, we're going to plug it in as negative 4 plus 5 over 2, comma, 6 plus negative 1 over 2 to find the x and the y. So this is going to give me a half. This is going to give me 5 over 2. Now I can't simplify that anymore, so that would be the final answer. You guys' homework is open on Canvas, but this is it for today's notes.